This is going to be a video going over graphing rational functions. This is a complete, over-the-top breakdown of every little nook and cranny of this topic. So some people may be able to fast forward, some people may be able to watch this on a faster speed, but if you're new to this, I suggest you watch it at normal speed and follow along and pay attention and have the PDF to go along with it so that we can copy everything down. First, we ask you for the factored form. Now, technically, you could say that this is already in factored form. I'm going to be a little over the top here. I'm going to rewrite this as an x minus 1 in parentheses. I'm even going to put a little 1 exponent right out there. Here, I'm going to factor out the 2. You don't need to do this. It is extra. If I factor out the 2 by using distributive property, this inside should be 3 over 2, or 1.5. But that is the exact same expression as that one right there, just changing the way it looks a little bit, okay? X intercepts. The way you get the x intercepts, in a nutshell, is by setting the numerator equal to 0 and solving, okay? So if you have to put a little note for yourself, something there, then go ahead and do that. If I set my numerator equal to 0, no, you do not need to set 2 equal to 0. 2 doesn't equal 0, it doesn't give you anything. If I set the factor equal to 0, essentially using zero product property, I'm going to get negative 3 over 2 comma 0, which is the same as negative 1.5 comma 0. Now I wrote even or odd, bounce or cut. The degree, which I forgot to put on my numerator here, is a 1, which is odd. So that means we're going to cut through the x-axis for it, okay? I guess I could have used blue since I did the x-intercepts in blue. As I find all of this information, I'm going to mark it up on my graph. Okay. From here, sorry, the focus is a little funny today. From here, we're going to do the y-intercepts. How do you get y-intercepts? Y-intercepts you get by setting x equal to 0. When we fill in 0 for x, we like to use expanded form. So here is my expanded form, and this right here is essentially my factored form. Two different forms of the same equation. X-intercepts, we like factored form. Vertical asymptotes, we like factored form. Y-intercepts, we like expanded form. Horizontal asymptotes, which is also our end behavior. Here we like the expanded form. So when we want our y-intercepts, we're going to fill in 0 for x. If I do that right up here, you'll get 3 over negative 1. 3 divided by negative 1 is negative 3. So 0 comma negative 3. You don't need to mark that as a bounce or a cut because you always cut through the y-axis. Vertical asymptotes, in a nutshell, we get by setting the denominator equal to 0. Asymptotes are equations, so I'll end up with x equals 1. X equals 1 is a vertical line. Your vertical asymptotes are a very strict restriction on your domain. Your graph absolutely cannot go to that area. All right, completely off limits, not allowed at all. Okay, so my domain will not include positive 1. Next, I'm trying to, there we go. Now I have my horizontal asymptote or end behavior. Now, as Algebra 2, sometimes you are asked to sort of just memorize what to do. We did have a full lesson on this otherwise. 2x over x is the part we pay attention to. Horizontal asymptote is really end behavior. End behavior means at infinity or negative infinity. The plus 3, the minus 1, they're not going to have a big impact. My leading term, 2x over x, that's what's going to have the big impact here. Now, 2x over x reduces to just 2. When the powers are the same on top and bottom, your horizontal asymptote is at y equals 2 over 1 in this case, so y equals 2. So I'm going to go over here, I'm going to draw a horizontal asymptote at 2. Keep in mind, horizontal asymptotes, you are allowed to cross those in the middle. Really, they're just guidance on where your graph looks like it's going, where it looks like it's headed. So my graph, as we go out towards the ends, will look like it's going towards the value of 2. Next, now I'm going to fill in some of my graph here. My graph definitely connects these 2 points right here, okay? I'm sketching, I'm not going to be super accurate. You always cut through your y-axis, so I'm going to be going down. I know it's not going up because I don't have another x-intercept. I can't turn around and come back up. I don't have an x-intercept. Here, my behavior, I'm going towards 2, so this is going to go out closer and closer to 2. This asymptote had a degree of 1. That also, should have marked that up, was an odd degree, and it means cut. Cut means in opposite directions, okay? If this side is pointing down, that means that this side is pointing up, and again, you're working towards, going out towards infinity, you're going to get closer and closer to the value of 2. Domain, if we start at negative infinity, we are good to go until positive 1. I have a parenthesis, it's not included. Right after 1, we're included again, and we're good until infinity. And the range we could pull from this picture as well, it's actually negative infinity until 2, and then from 2 until positive infinity. Essentially the same technique will work on the first bunch of examples in this packet. But for right now, we're going to use this example. I'm going to have you guys try the next few, and I'll come back with another video later.